All right, let's get into it and break down the whole scientific journey from start to finish. If you've ever wondered how scientists actually work, or maybe you're just getting ready for a test, this is going to walk you through everything you need to know.
Okay, so here's our game plan. We're going to start with the big idea. What even is scientific inquiry? Then we'll get into the nitty-gritty of planning a fair test, staying safe in the lab, and using your gear. After that, we'll talk about data and what to do with it, and we'll finish up with the most important tool of all, a scientist's mindset. So, let's kick things off at the very beginning, shall we?
I mean, have you ever really thought about it? It's so much more than just bubbling potions and lab codes. At its absolute core, science is just a special way of asking questions to figure out how the world around us works. And it all boils down to one super important word: evidence. See, science isn't about just making stuff up or guessing. It's all about gathering actual facts, either by observing the world, like watching how a plant grows, or by setting up our own tests, which we call experiments. And this whole process, it follows a pretty clear path. It always starts with curiosity, just asking a question. From there, you figure out a way to test it, you do the experiment, you look at what you found, and then, this part's key, you share your results so that other people can learn from what you did. But just having a question isn't quite enough. To get an answer you can actually trust, you need a really solid game plan. This right here is the key to doing good science. A fair test just means that you're totally sure that the one thing you changed is what caused the result you saw. And to make that happen, we need to get our heads around something called variables. So think of this as the cause. It's the one and only one thing that you're going to change on purpose in your experiment. If you change more than one thing, you'll have no idea what actually caused your results. And if the independent variable is the cause, this one's the effect. It's what you measure to see if your change actually did anything. Its value depends on the independent variable. See? Kind of makes sense when you put it that way, right? And these guys are the unsung heroes of every experiment. These are all the things you have to work hard to keep exactly the same. By controlling your constants, you can be sure that any changes you see are because of your independent variable and nothing else. Let's make this real with an example. Say we want to test how sunlight affects plant growth. The one thing we change is the amount of sunlight. That's our independent variable. The thing we'd measure is the plant's height. That's our dependent variable. And to keep it fair, we'd make sure the type of plant, the amount of water, and the soil are all identical. Those are our constants. Easy. Okay, plan's ready. Let's head to the lab. But hold on, before we even think about touching any equipment, we have to talk about safety. And seriously, this part is absolutely non-negotiable. These are the golden rules of the lab. And trust me, they aren't there to ruin your fun. They're there to make sure everyone stays safe so we can focus on the science. Things like always wearing your safety goggles and cleaning up your space. They're simple habits that make a huge difference. All right, now that we know how to be safe, let's get to the cool stuff, the tools of the trade. Knowing what equipment to use and when is just as important as knowing the rules. Here are some of the lab's greatest hits. You might use a beaker just to hold some liquid, but if you need to measure it, you'll want a measuring cylinder. And if you need to be super duper accurate, that's a job for a burette or a pipette. Using the right tool for the job is a massive step towards getting results you can trust. The Bunsen burner is an incredible tool, but you've got to treat it with respect. Just follow these steps every single time. So, air hole closed at the bottom, lighter ready at the top, turn on the gas, then ignite. You'll get a bright orange safety flame. Then you can carefully open the air hole to get that hot, roaring blue flame you need. Okay, the experiment's finished, the lab is tidy, and you've got a notebook full of results. Awesome. But what does it all actually mean? Let's figure that out. Your results usually come in two flavors. First, there's qualitative data. That's descriptive stuff, what you can see, smell, or hear. Think quality. Then there's quantitative data. That's all about numbers from your measurements. Think quantity. You almost always need both to get the full picture. Now, these two words, accuracy and precision, are super easy to mix up, but they're totally different. Accuracy is about how close you are to the real true answer, like hitting the bullseye on a dartboard. Precision is about how consistent you are, like hitting the exact same spot over and over, even if it's not the bullseye. The goal, of course, is to be both accurate and precise. Look, nobody's perfect, and neither are our measurements. Errors can sneak in. A zero error is when your scale is off from the start. A parallax error happens when you look at a measuring cylinder from the side instead of straight on. Knowing about these common slip-ups helps you avoid them and makes your data way more reliable. So we've covered the plan, the safety, the tools, and the data. But there's one last piece to this puzzle. And honestly, it might just be the most important one of all. It's all about your mindset. You see, being a great scientist isn't just about what you know. It's about how you think. It's about not giving up when an experiment goes wrong. That's perseverance. It's about that little voice in your head that's always asking why. That's curiosity. And it's about being totally honest with your results, even if they aren't what you hoped for. That's integrity. These are the things that really push science forward. And that's it. That's our full tour of the scientific endeavor. You've got the map, you know the rules, and you've got the mindset. The only thing left to do now is get out there and explore. So I guess my only question for you is, what are you curious about?